Hi there. So this is the fifth and final recording for October 7th, 2025. I'm actually recording this on October 1st, 2025. And as I mentioned in class, we will not have a face-to-face class on the 7th. However, your job is to watch the videos in this section on our Moodle page. There are a total of 5 videos. But the good news is that you will only have um, you will only have about 36 or 40 minutes of viewing time. So since our class is an hour and 15 minutes long, you will have less time than that, and you'll have some time for yourself. So the next part I wanted to show you is how we monitor the power that we're generating, and also the difference in electrical units between power and energy. So over here on the right side of your screen, you'll see it says Enphase. That's the name of our system. And there are some different features that we can use to determine what we have going on. So right here, the first thing you can see is that the system is normal and we are on grid, and that our batteries are charged to 100%. Now, this is a little grid, not of our power, but of our energy. And the difference between power and energy is an amount of electricity that you've generated, and power is the rate or the speed, so to speak, at which you generate the electricity. So everything here, if you notice, the units are kWh. That stands for kilowatt hours. And a kilowatt hour is a unit of energy. A kilowatt, if the H is not present, kilowatt is a unit of power, or how fast, or the rate at which you're generating energy. So this screen shows us amounts. The first thing that you notice is it tells us about what happened all day long today. We have imported 0.2 kilowatt hours. We have produced 34.2 kilowatt hours, and we have used 2.5 kilowatt hours from our batteries, for a total, after you take off what we've exported and charged, of 6.8 kilowatt hours consumed. So basically, if you take everything that comes in and everything that goes out, if you take these and add them together, and subtract the output from the input, you would get 6.8 kilowatt hours. So what you notice is we have imported 0.2 kilowatt hours, and we have exported 23 kilowatt hours. So that looks like which is true, we have a net export of power. So we are making more power today than we have used. We're making more energy today than we have used. Pardon me, I shouldn't have said power. But basically, why do we have 0.2 kilowatt hours imported? Well, that probably happened this morning before the sun came up. If you get up, it's also kind of fun to watch because there's a live feed. And as soon as appliances kick on in your house, you can see that your energy consumption, or the rate at which you use energy, the power goes up immediately. So over here, it tells me that my grid dependence has been 3% today, and my solar offset is 504%. So that just means that I've used 504. I've used about a fifth, or about 20% of what I have produced over the course of some period of time. So it talks about some energy equivalents in terms of how much carbon dioxide reduction there's been. Because one thing about solar power, it's not the only power, but that does not create a carbon footprint, or does not produce carbon dioxide. Wind power does not produce carbon dioxide, and neither does nuclear power. But anything that involves, and also hydroelectric. So energy coming off dams does not produce carbon dioxide. But that is a meaningful statistic to a lot of people. So I just wanted to point that out to you. If I go to the next screen, you can see my total energy for October 1st, and you can see that we have color changes. The light green is where I'm charging the batteries or discharging the batteries. So if you look at this graph, if I go above the graph, that means that I am using power from the batteries. And if I go below the graph, that means I'm storing power from the batteries. So this is what I'm making and this is what I'm using. Okay. So, and you notice it's just at 0. So everything above is, I guess you would say, positive, and everything below is a negative. So if you look at that grid, for example, take a look at what's going on right here. Okay, this is early morning. So during the night, we're not really using a lot of power. And then we start to use power when we wake up in the morning. And at that time, we're actually using power from the batteries because the solar panels aren't making power. Then morning comes up and we start making power, and that's what we have going on in blue here. So it sort of goes up. There's a little peak right here, which is pretty interesting. And when we peaked, we start exporting. So this is stuff that goes out of the system. In this case, it goes into the grid when it's black. All right. So this is just talking about at different times. And it tells you, like right here, you can look at the numbers change above the grid. If you just get one of those bars, it shows you that interval of 15 minutes during the day. Okay, so like if you look at this interval right here, which is, you can see that I'm not discharging, but I am actually not importing. I'm using very, very little power at this point, and then it moves up a little bit, and so forth. I don't start really exporting until 10:30. No, not even at 10:30. There we go. Start exporting at 10:45 in the morning today. Right, now this is just for the day, but you can see we put this system in June, and so there's also a from the beginning of time, which would be the same as the year for us. If you look at the month, that's just October, right? But the week actually goes back further. So you can see the date range, and you can see what our different what those 4 different factors are: how much we produce, how much we consume, how much we import or export, and how much we charge or discharge. And then you can also see what the solar offset looks like, and so forth. Okay, now, like I showed you, I had taken my drone and taken some pictures of the array, but this is a schematic or just a picture of the array itself, 26 panels, and it talks about what my production is in kilowatt hours. And once again, that's energy, not power. Since these panels are connected together, they should all be producing approximately the same power, and they should have produced over the course of the day approximately the same amount of energy. So you can see that that is true. If one of them was producing less, it might be dirty, or it might be not producing. There might be something mechanically wrong with the panel. All right, so then the last screen that we can talk about is the live status. And the live status shows us what is happening just right now. So you can see that from the solar panels, I am producing power at a rate of 6.1 kilowatts, 6.2 kilowatts. There's nobody at my house right now, so I'm consuming 0.3 kilowatts. So I'm charging my batteries a little bit, and I am exporting quite a bit of power to the grid at this point. All right, so that is the last of those videos, and everything is available to you, so you can watch them anytime beginning now. But I will not see you on October 7th, but I will see you on October 14th. And until then, have a great day.